In this video, I just wanted to go over a few questions that people had on worksheet 3. So in the first few problems, what you're going to do is basically know all the way around the circle is 360, all the way around again, you add another 360. You can use the fact that there's 90-degree angles in there and 180-degree angles in there. If you want me to go over these, let me know. In the second set of problems, what you're doing is state the quadrant in which the terminal side of each angle lies. So what I like to do is draw it out, and if I know I'm working with a negative angle, I know I'm going to be moving this way. So in this first problem, obviously we're starting at 0. If I go this way a little bit, I'm at negative 90. If I go another 90 degrees, I'm at negative 180. If I go another 90 degrees, I'm at negative 270. And then I know if I go all the way around, that's negative 360. But I only need to go 20 more than that, so I'm just kind of going to go right here. And there's my angle, which means I'm in quadrant 1. You also asked about number 10. So in number 10, negative 108 degrees. What you're going to do again, we're going to be going clockwise now. So we're going to be going this way. If I go here, I'm at negative 90. If I keep going and I go to negative 180, that's too far. So I'm really just going to go 18 more degrees, so maybe somewhere over here. That means I'm in quadrant 3 because I'm at 1, 2, 3, 4. So in this case, I'm in quadrant 3. Now on the back, for figuring out if two angles are coterminal, what you're going to do is see if they're 360 degrees apart. So in the first problem, if I take 305 and I subtract 360, I end up at negative 55. So that means this one works. Something like 25 for number 12. If I take 25 and I subtract 360, then I'm going to be at, let's see, 25 minus 360, I'm at negative 335. If I subtract another 360, I go way past negative 385. So that means that 25 and negative 385 are not 360 apart. So not 360 apart, or some multiple of 360. In something like 13, what you're going to do to test this out is say 135 minus 360. That's going to be negative 225. Now try it again. So do negative 225 minus 360. And then we're at negative 585. Well, I just went past negative 495, so they can't be coterminal because they're not 360 apart. In the next problems, what you're going to do is find a positive and negative coterminal angle for each angle given. So in something like number 10, what you do is say, well, 10 plus 360, that's going to be 370, so that's an option. I could also take 370 and add another 360. That's 730, that's also an option. On the other hand, I can take 10 and subtract 360, and then I'm at negative 350, so that's an option. So all you're basically doing is saying you're at some angle 10, and figuring out what's another way to get there. Well, I could get there by spinning once. I could get there by spinning once and then spinning all the way around again. So then I'm at 370. I could also get there by starting here and spinning backwards. So you're just spinning around until you're in the same direction. So think about sitting in one of those wheelie chairs and just spinning around and around, but then you always end up facing the same, like window or painting or whatever it happens to be. So to figure out how much you've spun, you add 360 multiple times or you subtract 360. You're going to do the same thing in number 16. So you take negative 345 and add 360 to get 15, or subtract 360. And again, you could add 360 again and again. So there's going to be endless correct answers for this. In number 17, if you're at 676, you can subtract 360 and you still have a positive number. So you still have 316 in this case. you could have also added 360 and gotten another positive. To get negative 44, you had to just subtract 360 multiple times. So you just subtract until you get a negative number. In number 18, you can add 360. If you really wanted to, you could take 345 and add 360 again. And so 705 is also an answer. Or you could add 360 again, and 1065 is also an answer. So there's a lot of options that you can do for these problems. Last up, the problems that you guys probably struggled with the most is if you're given a point and you have to figure out the value of the function. So the first thing that you have to do is figure out what you're working with. So in this, 5 is x and y is negative 20. So on your graph, if you think about where positive 5 is, well, that's going to be over here. Negative 20 is going to be down here. So we end up with a point down here that's 5, negative 20. Now you're going to make your angle. So here's your triangle. And to get there, we had to go over 5 and down 20. Now you're going to use Pythagorean Theorem to figure out the other side. So you're going to say 5 squared plus, and make sure you put in parentheses, negative 20 squared equals x squared. When you solve for x, you find that x is 5, the square root of 17. So you have to get that by using your factor trees. So here we have 5 square root of 17. And now we're ready here. And remember, theta is always up in the corner towards the origin. So what you're going to do to figure out sine of theta is you're going to say sine of theta opposite, so negative 20 over hypotenuse. And now simplify. So this 20 and 5 can simplify to 4 over 1. So this becomes negative 4 over square root of 17. And last up, there's a lot to do in this step. You have to rationalize. So multiply by square root of 17 over square root of 17. So your final answer is negative 4 square root of 17 all over 17. So that's where that one comes from. Let's try number 20. So sometimes you guys panic a little bit because you see something like a square root right here for x. Remember, that just means x is some positive number. It really doesn't matter what the square root of 19 is, but if you really wanted to know, you could plug this into your calculator and do square root of 19. And so this is about 4.35. So just think of it as a number, as if it was 4, but we're just going to label it square root of 19. So what you're going to do is draw your triangle. So I'm working with a positive number. It's square root of 19, which is really just 4.35 about, and then I'm working with a positive 9. So now my triangle, my x is square root of 19, and my y value is 9. Now, luckily, since we want tangent of theta, we don't even have to find the hypotenuse. It's just opposite over adjacent, so it's just 9 over square root of 19. Now we're just going to rationalize by multiplying by the square root in the denominator, and then we get 9 square root of 19 over 19. Because remember, a square root times itself is just that thing on the inside. So there's our final answer. And maybe we'll try 2 more. So in this next problem, we want to figure out sine of theta, and we've got a positive x and a positive y. So if we have a positive x and a positive y, we know we're in this quadrant. So let's draw our triangle. Here's our triangle, here's theta. So our x value is 13 and our y value is 16. Now I know I need the hypotenuse, so what I'm going to do is take 13 squared plus 16 squared and say it's equal to x squared. If I do that, 13 times 13 is 169, and 16 times 16 is 256, is x squared. So then x squared is equal to 425. And what I have to do is figure out what x is equal to. So x is equal to the square root of 425, and I need to figure out what multiplies to 425. So 425 is actually 25 times 17, so that's 5 times 5 times 17. So this means this is square root of 5 times 5 times 17. These 5s are paired, so they get to leave the house as 1. So this is 5 squared root of 17. So you have to do all that work just to figure out the hypotenuse is 5 squared root of 17. Now, once you do that, what you're going to do is figure out what sine is. So sine is opposite over hypotenuse, so 16 over 5 square root of 17. We can't have a square root in the denominator, so what we're going to do is multiply by square root of 17 over square root of 17. So this becomes 16 square root of 17 all over 5 times 17. That 5 times 17 is going to give us 85. So there's our final answer. And let's just do this last one to make sure that we've got it. Tangents are usually actually the easiest if you're given a point because you don't even really have to solve for the hypotenuse. So in this case, we've got a negative number. It does not matter that it's square root of 7. It's really just another negative number. So a negative x would go over here, and a negative y would go down here, and they'd meet up. And we'd have our triangle right here. So remember that negative x is just negative square root of 7. It really doesn't matter that there's a square root there. And then we go down 3. Now, our tangent of theta is opposite. So opposite is negative 3 over hypotenuse is, opposite over adjacent is negative square root of 7. Now, we can simplify that so it becomes positive because it's a negative divided by negative. And finally, we're going to rationalize by multiplying by the square root in the denominator. So we end up with 3 square root of 7 all over 7. So let me know if you guys are still struggling with this or if you have any other questions. I'd be happy to do another video for you.